Recording will start momentarily. Okay, we are now recording. So, okay, well, there it is right there. Don't ask your neighbor, just see if you know it, okay? And I see people already asking each other, just see if you know it. The barium ion and the phosphorus ion. I'm not even going to name them properly yet, okay? And what's the charge on the barium ion right here? 2+. Okay. Barium is going to be that. And let's see, the one I'm calling the phosphorus ion. How about you serve your hand up? Yeah. -3 it is. All right, now, so we got the barium ion and the phosphide ion. Remember, IDE indicates negative. Okay? Now, why don't we say barium 2 ion? Over there, what? Because there's only one charge. And like I said, always pretend like you're talking to a chemist. And if you say barium 2, he's going to think, what do you think, I'm an idiot? Of course, that's the only one we've got. Now, if I say iron, well, we may not remember the charges, but just remember it's in there, the transitions. Okay, it does have more than one charge. So you have to specify iron 2, iron 3. All right, now what I'd like to do is start the lecture, now that you guys successfully named these, with the statement that compounds are always neutral. And this is for not only covalent compounds, but also, more importantly for today's lecture, ionic compounds. You cannot have a charge. Okay, a little later in the lecture, in fact, in a few minutes, we're going to start into what we call polyatomic ions, which way to describe them, they're covalent compounds with a charge. But they're not technically referred to as compounds because they are not neutral. Okay, we'll be doing examples of those. But the first thing is compounds are always neutral. So if we're going to make a compound out of the barium ion and the phosphide ion, what would be a good combination that would give us a neutral situation? Sorry? Somebody? Okay, I just heard this, Ba3P2. And she is totally and absolutely correct. Now, one way you can approach this is we have a 2 and we have a 3, and the common common number would be 6. So basically 2 times 3 is 6, and, excuse me, what do I got? 3 times 2 is 6, and 2 times 3 is 6. So that will work out. There's another way you can do it in the heat of an examination, is just drop down diagonals like that. Don't drop down the charge, just the number, okay? So you don't have a negative and a plus there in the subscripts. But that's another way to do it, okay? Let's try one more just for a review here. Okay, let's say we have aluminum ion and oxygen ion. Figure out the charges, write them down. Take a second, maybe 2 or 3. 2 or 3 seconds is up. And let's see, how about you over there, sir?
Al3 plus O2 negative.
Al3 plus 2 negative, completely correct. Remember, it's not aluminum 3 ion, it's aluminum ion. And it's not oxygen ion, it's oxide ion. Whenever you're naming compounds, regardless if they're covalent or ionic, the positive always comes before the negative. Okay? So, somebody else? How about you, sir, right there? White shirt there. What would be the formula for this for the combination of these ions? You got it. Al2O3. Now, something I failed to do here, which I'll do right now, is who would like to name this compound? How about you, buddy, right there, sir? Pointing right. Don't look behind you. Right here. There you go. How would you name it? Whoa! What's on the board? It's on the board. Oh God, yeah. What do you think? Yeah, keep going. Don't stop now. We're hanging on your every breath. Okay, how about you, sir, right next to him? Green shirt, sir? What do you think? What was that? Double aluminum. What? No. Sir, your hand up. Barium phosphide. Okay, remember, guys, just drive it home. Ionic compounds, you do not use prefixes. That's why I went through that big discussion about when you have a chunk of ionic compound, you can't say exactly how many are in there. Okay, so you go up the lowest ratio. Okay, so this one here would be barium phosphide. Okay, barium phosphide, not tribarium diphosphide, barium phosphide. Think of when you're naming ionic compounds, think of it as the formula for the combination of barium ions and phosphide ions. So barium phosphide. You're not talking about individual molecules where you have to basically indicate how many of each. All right? You always go, by the way, what's it called when you have a formula in the lowest ratio? What's that called? How about you, buddy? Okay? What is it called? Empirical formula. Okay? All good stuff. Now, who would like to name this one? Name that compound, the newest show on TV. Again, you? You're taking up everybody's time. What? Aluminum oxide, yes. Okay? Now, we should have... You guys going to remind me when to move the camera? Today it'll be solely your responsibility, okay? Solely your responsibility. All right, so we got that. Okay, now what I want to do, because we kind of not rush through it, but we got a lot of material to cover today. We've talked about monatomic cations, monatomic anions, okay? We've talked about monatomic cations with just one charge, the ones in group 1A, 2A, and then aluminum in 3A. Then we've talked about monatomic anions with one charge, -1, -2, -3. Okay, so that would be group 7A, 6A, and 5A. Remember, noble gases, no charge. 4A, no charge. Okay? Now, what I'd like to do is talk about something that we call, move the camera back here. They're called polyatomic ions. Okay? Now, there are several tables in this chapter that you have to memorize. Okay? If you open your books, you can see it's going to be, and some of them are pretty trivial. Actually, what I'd like you to do is take a few looks at figure 217. Okay? Figure 217. You don't have to memorize it, but just check it against a periodic table. It shows you those charges we've already talked about. Then it gives you some of the transition metals. I don't expect you to memorize the transition metals, just the ones that we talked about in class. Okay? Let's see. Then there's table 2.3, 2.4, 2.5. There's a little one on 2.7. And that's pretty much it. So it's what did I start with? 3? Okay. Also, get down tables 2.3, 2.4, 2.5. Okay? Now, there's the other table in here that's got the prefixes in it, so, I don't think you have to know that. Where's the prefix table? Well, it's in here somewhere. Pardon me? Oh, there it is on page 69, table 2.6. Okay, you're going to have to memorize those. Now, what I'm going to do right now is I'm going to give you about 6 polyatomic ions. I want you to get those down first. Okay? They're not that hard. You just have to spend a little bit of quality time with them. And then I'm going to give you about 3 rules that are very, very, very simple. And they'll allow you to take any one of those polyatomic ions and all of a sudden come up with other species with their own names. Like I'll do phosphate for you, I'll apply the rules, and all of a sudden where you start it with just one, you'll have 8 different chemical species with their names. And it's not that hard. All right, now let me just set you up for what's going to happen here. When you do this, I think you'll see the method fairly easily. Okay, but it doesn't mean like in a very short time you'll be able to whip these formulas off the top of your head. Don't worry about taking time to do it. It's pencil and paper time. If I say dihydrogen phosphite, well, you're going to have to think back the relationship of phosphite to phosphate, dihydrogen, what that means. Okay? So it's going to take time, but, with some practice, you'll get fairly good at it. And don't worry if you don't master it, in a couple of days. But it'll build some familiarity into it, so when you do go to these other tables and start memorizing some of those things, it'll be more familiar to you. You just won't be blindly memorizing. You'll actually see how they're related. You're also going to learn a lot more nomenclature this way. Okay, so in exam, I can give you examples from them to put on the board today. It's not that hard. And you'll see examples of them in the tables. Everybody with me? And I'll also like to say nomenclature is not a lot of fun to study, especially when it's a nice day like today. But get it down. You're going to a foreign country. Let's get down some of the language is what we're doing right now. All right, so enough of my preaching. Let's get back to lecturing. All right, let me move my camera since my assistant is sleeping. There we go. There we go. All right, don't look at that. You can be my assistant now, okay? There you go. Sorry about that. These things happen. All right, so, we'll have polyatomic ions. Okay? I'll start out with an example here. NO2, NO2 minus. Tell me something about what's there on the left-hand side. You see NO2. Tell me about it. What is it? Anybody? Sir, how about you? You. Every time I point, people look behind them. You, goatee.
What do I see?
Yes. When you see NO2, explain it. What is it? Compound? What? Looks like what? Nope. 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 Somebody, tell me more. How about you, sir, on the blue T-shirt? Yeah, you got a blue T-shirt. You look down and see if you had a blue T-shirt on. Usually people look behind them. You mean, just going, yeah, it's blue. Come on. All right, somebody else. You, sir. How about you? Covalent. Bond? Compound. Covalent compound. How do you know? No. Oh, behind you. He's all anxious. What? It's nonmetals. You guessed right. You just don't know why. It's made up of nonmetals, ladies and gentlemen, introducing the covalent compound. Now, somebody, name that compound. Okay, how about you, lady? Okay. Yeah, you pointed to yourself. Okay, go. Nitrogen oxide? How many oxygens are in there? Dioxide. You say nitrogen oxide, they'll say, well, I know what you're talking about, but that's still not correct because it would have been nitrogen monoxide, but there are 2 oxygens. Oxygen dioxide. Remember, it's a little molecule, and you got to indicate all the atoms. Ionic compounds are big, bulky lattices, and he's got them all over the place. Okay, but the compound covalent, they're all neat. You just got to specify how many atoms of each. Nitrogen dioxide. So this guy here is going to be a covalent compound. And it's going to be called nitrogen dioxide. Okay, now I don't think you're going to know this one unless you were really, really, really good in chemistry before and you're just kind of floating through the class. But this guy here, and this is what I want you to start focusing into. You see a formula, but there's also a charge. Okay? Okay, now compounds are neutral. Okay? This has got a charge, so it's not a compound. When you start doing Lewis structures later in the semester, in fact, towards the end, you'll see that like NO2 and NO2 minus, structurally they're very, very, very similar. Okay? They have covalent bonds, all kind. However, the guy on the left, or on the right there, excuse me, on the right there has a charge. So he's a polyatomic ion. Can I do what? Yes, I can. Just give me half a second. I'll lower it for you. Polyatomic ion. Tech person number 2 today. Good. 3, actually. Like that? Up a little bit. I'm not taking a wedding picture down here. You know?
A little to the left, a little to the right. Smile. Smile. You're not smiling.
Okay? Okay. So this means you're coming back Monday, right? Okay, good. All right. I want to make sure everybody's happy, right? Am I happy? I don't know. But we're here. This is quality time. It's Friday. Thank you for reminding me. All right, so let's talk about this now. We think of polyatomic ions as covalent compounds with a charge. Okay? So polyatomic ions, they are like covalent compounds with charge. Okay? Think of them that way. They're still called ions, even though they're covalently bonded together and everything. They have a charge. Okay? Now that nitrite that I just put up here, I didn't put the name up here. This is called the nitrite ion. We'll learn all about that guy today and the other ones. Okay? He behaves just like another single, let's say another -1 charge, like chloride, fluoride, bromide. Behaves the same way. It's just bigger, but it performs as an ion. Okay? All right, now, nobody told me to move the camera again. Uh-oh, everybody's fired. All right, well, let's just come over here. Okay, there we go. In fact, let me come back this way in case people playing the home game couldn't see it. By the way, did I tell you guys I talked to the tech people? Why isn't that thing focusing? I talked to the tech people, and they said that we cannot, I can't remember if I mentioned this in class, but we cannot watch this real time at home. That's another program that I'm not set up to do. Sorry, but you can go home and watch it and, relive that moment, if you will. Okay? Wonderful. Yeah. Here's what I want you guys to do. Feel free to start memorizing some of this stuff, like the monatomic cations and all. That's fine. But as far as the polyatomic ions, what I'd like you to do is start memorizing what the sulfate ion looks like. Okay? Let's do what the phosphate ion looks like. Okay, let's move this. Oh, that's fine. Okay, how about the nitrate ion? The carbonate ion. Okay, the chlorate. And also very similar to that, the bromate right below the chlorine. Bromine's right below chlorine. That'll be bromate. And the iodate ions.
Turn the rest to go down a little bit.
Do you what? How's that? You're doing your job. Thank you very much. Okay. Take the rest of the day off. Go out and do whatever you want. All right, now, the chlorate, as you can see, ClO3, BrO3, IO3. One is right beneath the other on the periodic table. They are halogens. And usually I just tell them to do the chlorate, then later I mention these guys are exactly the same. But it probably wouldn't hurt just to see them all together like that. Bless you. Okay. Here we go. Now, this board's going up, another board's coming down, so you can continue to write. And what I want to do is show you guys a couple of rules that we can really increase that number. And as I told you before, what can happen to phosphate, that's what I'm going to do. I'm going to do something to phosphate. Let me pull it out just a little bit. Oop, too much. That should do it. There we go.
Why did they become charged?
Why? They picked up electrons. I can't account for exactly what they were doing at the time, but it was on a Friday. They had very negative attitudes. And all of a sudden, zap, they picked up a negative charge. Isn't that right, Dr. Goganaya? Yes, they do. And he's a physical chemist. He should know, right? All right, so here's what I'm going to do, ladies and gentlemen. We're going to take a phosphate ion. I'll even put the name under it if you don't believe me. Phosphate ion. Now, the first rule is this. Well, no, I won't tell you the first rule yet. I'm going to show you the relationship of phosphate to this guy. H3PO4. And that's called phosphoric acid. Phosphoric acid. Okay? Now, there's a relationship there. If you were to take some phosphoric acid and hit it with base, enough base to knock off those 3 hydrogen ions, guess what you get? You get the phosphate ion. Okay? Or if you get, let's say, sodium phosphate, okay? Sometimes you get this stuff at hardware stores like Home Depot. They say, try sodium phosphate. Maybe it's TRY. I don't know. But anyway, just sodium phosphate's fine with me. Anyway, you could acidify it and get phosphoric acid out of it, too. Okay, you can do that. But we're not talking about how to obtain one from the other. I'm just going to show you the relationships, okay? So let's start up here at the full phosphate ion and work our way towards the acid. Now, if I've got PO4 minus 3, how many plus 1, I'll say it just to emphasize it, not that it's the correct way to say it. Oh, what the heck. How many hydrogen ions can you basically put together with that phosphate? Don't anybody hear you? Okay. 3, she screamed like that. Okay. Right. You can put 3 on there. What we're going to do is we're going to start throwing hydrogen ions to these polyatomic ions until we get this neutral compound, which is what I like to call the parent acid. Some books call it that, other books totally ignore that. But I like the idea because it kind of lets you see where it's coming from. So here's what we're going to do. We're going to take phosphate, and we're going to add 1 hydrogen ion to it so it looks like this. Okay, now the phosphate had a -3 charge. We just put a hydrogen ion with a +1 charge. What is the net charge on the ion now? -2. All right, not bad for a Friday, guys. Maybe I'll go home and let you guys take care of this yourselves. Okay, now what's this called? Very, very easy. It's now called hydrogen phosphate. It's that simple. Okay? Now, let's take this hydrogen phosphate and let's hit it with 1 more hydrogen ion. So now it looks like this.
Camera.
Excuse me? What?
Camera.
Camera. Action. Okay, what's my motivation, though? What do we do? I didn't read the script last night, so I'm not sure what's happening today. All right, here we go. Better? All right. So now we have 2 hydrogens on here. What's the charge going to be? -1, or just say negative, that's fine. So that's going to be called dihydrogen phosphate. Now, I used a lowercase d, so what? I just did that off the top of my head because I felt like it. Okay. I'm going to move this guy over just a little bit. And we'll put that final hydrogen ion on it. And now we're going to have that one I just talked about, H3PO4. No charge. This is now called phosphoric acid. Okay, so throwing hydrogens at it. 1 hydrogen, 2 hydrogens, di. This one, you're not going to go higher than 3 hydrogens, okay? But just to show you how it can happen. Now, something to keep in mind is this. Phosphate, phosphoric acid. Whenever you have a polyatomic ion, that's good. They're all on there. That's good. Okay. Let me move the board, the camera, just a bit to write this down. Then I'll go back. But ATE ions go to ic acids. Sounds kind of funny. It's amusing. Okay? So phosphate, phosphoric. Sulfate, sulfuric. Carbonate, carbonic. Acetate. Acetate? Acidic. Acidic acid. Of course acids are acidic. Acetic acid. Vinegar, right? All right. Is it still blue? All right. Keep us posted. All right. All right. So let's go back here. I'm so glad it's Friday. Really. I'll get that first seat on the bus after class. I really will. Okay. Now here's something else we can do. We don't have to, but if it happens, if we take like phosphate and knock off one oxygen, and the second part is keep the charge the same. Say that in your sleep tonight before you go to bed. Or go to bed and then say it before you fall asleep, okay? All right, so now we're going to have PO3 minus 3. And now this is called phosphate ion. Phosphate. So I told you guys to memorize sulfate, nitrate, carbonate. Well, no, carbonate doesn't have a carbonate because it's too unstable. So forget that one right now. But you take your ATE ending there's my hand. You take your ATE polyatomic ion. If an oxygen falls off, it's called phosphite, sulfite, nitrite. Okay? Chlorite, bromite. So now we got a new ion. Let's do the same thing. Let's start throwing hydrogen at it. So we got HPO3 minus 2, hydrogen phosphite. Very simple. Hydrogen phosphite, and it's called, the complete name is hydrogen phosphate ion. Okay. Now we'll put another hydrogen on there. And now we got H2 going, H2PO3 minus 1, or just minus. And now this is called dihydrogen phosphite. Okay, ion. Now the very last hydrogen is going to give us the full acid. And where we had phosphoric before, now with one less oxygen, it's called phosphorus acid. Phosphorus acid. Okay, so the ATE endings go to ic acids. The ITE ions go to us acids.
Camera.
What?
Camera.
I'm doing that right now. You're not union, are you?
No.
Good. I just want to see how much I'm paying you for this. All right. So ATE goes to ic acids. ITE goes to us. So on the way home, you can chant it, ate, ic, us. No, ite, us. I mean, you know, no one will sit around you, but you can do it that way if you want. Okay. Okay, from what I put up here, if you look at the board, it kind of knocks you out sometimes. There's a lot of stuff up there. But just when you sit back and just kind of think about the method here, how many of you guys think that this is okay? Yeah. This is pencil and paper time. Okay? Don't go home tonight at dinner trying to press your family and friends by whipping these names off, because it's not going to happen. You just end up leaving the table in tears. Okay? Don't do that. Stay there for dessert. Okay? Get out a napkin. paper napkin and just start writing these out. Then you can impress them that way. Okay? Later you get better at it. All right? So when you look into your table here, okay, they have phosphate, then they have a dihydrogen phosphate. They have nitrite. Now, a couple in here, like permanganate, memorize it, but don't worry about the origin. That gets you into inorganic chemistry, and the nomenclature is a little bit different. Or dichromate. There's some in here you're just going to have to memorize. But the thing is, they're also in here, there's some in here that, like I have hypochlorite. Like, what's that about? But I think by showing you the method to this, it'll make it a little bit easier. And on exams, if you see dihydrogen phosphite, if you can remember what phosphate is, and remember a couple of rules, you can kind of backtrack it, whatever, to figure out what the formula is. Okay? So, like I said, don't just practice it. That's the main thing. What I'd like you to do over the weekend is do this exact same thing to those other ones. It's just as practice. Don't hand it in. I'm not going to give you credit, but it'll help you. All right? And also, take note that carbonate does not have a carbonite. Am I correct in that? Yes. It's just, you could form it. Maybe on Star Trek they can make it or something, but not here on planet Earth in the 21st century. It's just too unstable. So just carbonate. Now, let me just give you one more thing here real quick. And that is when you have this guy, okay, what do you think you'd call that guy? Hydrogen sulfate, correct. There's two names for it, though, okay? There's hydrogen sulfate, and there's an older name that they still use, which is, boink, 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 that's not right, which is bisulfate. Okay, bisulfate, okay? The same thing with this, HCO3 minus 1. CO3 minus 2, you probably haven't memorized it yet, but that's carbonate. So this would be hydrogen carbonate. And another name for it is bicarbonate. You guys might have heard of bicarbonate of soda, that type of stuff. If any of you guys have ever made wine or beer or something like that, you use this thing called dihydrogen sulfite, or bisulfite, I think they call it. It just basically is something to keep the bugs away. But when you see the bi, what was that? Is it time for us to go up to the magical kingdom or something? Or what? She's so serious, so serious. All right, loosen up, guys. It's only chemistry. Come on. Yeah, so do this with the other ones. Now, I tell you what. I know you don't have the names down yet, but let's put them to use. Oh, no. Before I do that, I'm going to do that. Before I do that, I'm going to do this. Okay, before I do that, I just want to hit one more thing here. There we go. Nope. Come on. There you go. All right, good. All right. This is one of the guys I gave you. Gave you chlorate, which is Cl. Did I? Oh, this one's already taken. Right, good. Okay. Got a little flustered when I forgot this. ClO3. Okay, and that's going to be chlorate ion. Okay, we lop off one of the oxygens. It now becomes chlorite ion. Okay? Now, if I put the one hydrogen, because it has a negative one charge, it takes one hydrogen. One hydrogen ion. That's important to remember. Not an atom. Okay? What do you think you call that acid? Chlorate, what do you call the acid? Hydrochloric is one of the answers, is it right? Okay, what should it be? Chloric. Yeah, chlorate to chloric. So this would be chloric acid. Okay? And this guy here would be what? No. Chlorus. Remember? ITE. Boing. Oh, there it is. ITE ions go to us acids. So this would be chlorus acid. Okay. Now, what I'm going to show you, a little rule here, is only going to apply to, they should be here, hopefully. Yeah. What I'm going to show you now is only going to apply to chlorate, bromate, and iodate. Let me just, for those guys playing the home game, they can see it here. There you go. Chlorate, bromate, and iodate. Okay, these are the only ones that these extra rules are going to apply to. Okay? So has everybody got that? Let's take this up. Bring this down. Bring this over. I'm getting pretty good at this. There you go. Maybe I should work for Fox TV. All right. The chlorite, it turns out we can take off one more oxygen to get this. Okay, now this is called not chlorite, but hypochlorite. Hypochlorite ion. Now that can take one hydrogen, is that correct? All right. HClO, like that. That's going to be hypo, you just bring the hypo with it, chlorous acid. Hypochlorous acid. Let's see if that all got on camera. Not bad. Okay. Hypochlorous acid. Now, the second thing we can do is we can get the chlorate and put an additional oxygen on it. So we'll have ClO4 minus. And now this is called not chlorate, but perchlorate. And the acid isn't called chloric acid, it's called perchloric acid. Okay? Now, the per and the hypo right now is we're only going to use it in reference to the chlorate, the bromate, and the iodate. Okay, so if I say hypoiodous acid, well, HIO, okay? Sounds like Ohio, doesn't it? HIO. All right, so I know here you'll see permanganate. Okay, don't worry about that. Just memorize that one. Okay, dichromate. What's that? I don't know. Okay, just memorize. Those are inorganic stuff. All right, but anyway, as far as these two additional things like the per and the hypo, only for the chlorate, bromate, and iodate. Everybody okay with that? Okay, let's clean up one more thing here. Tell you what, let's just, guys, we got about 7 minutes, so don't take off your parachutes. Yeah, let's just leave it with this right now. What the heck, I'll do this. There you go. All right. How do you name this ion? Chloride. Now, when I teach this, I always emphasize the end. I say chloride, but don't walk into a store and name it like that. They'll call security. You know, give me sodium chloride. I'm just trying to emphasize that you get used to it. This here would be chloride ion. Okay, now this one down here is the what? Chlorite ion. Okay? So chlorite. Okay? The IDE, when you're talking about ions, okay, they're going to refer to monatomic ions, like just fluorine or bromine or iodine. Okay, oxide, chloride, bromide, fluoride. Okay, the IDE. Now you see IDE in like a polyatomic ion like hydroxide. Okay, OH minus 1. Cyanide, CN minus. Okay, so the IDE, whenever you hear it, okay, that's going to indicate that you've got a negative charge. In a covalent compound, it just means it's indicating which atom is more negative than the other. Carbon monoxide. It's not an oxygen ion. It just means that the oxygen in the formula is more negative than the carbon. Okay, so you always have positive, negative as far as the order of the atoms. And also of the ions in these guys. Now this guy here is this is the chlorate ion. So we got chloride, chlorite, and chlorate. Now the acids, and like we just did this, so I don't think you forgot it yet, but the acids here would be, this would be chloric acid. Okay, this one here, HClO2, is going to be chlorous acid. What am I doing? Oh, there we go. Chlorous acid. Now the guy up here, and I heard this name before, and it wasn't correct how it applied to the question. If we had HCl, now this is called hydrochloric acid. Okay? So the thing is, the names sound very close. Chloric acid and, oh God. Oh my Lord. I'm rushing to try to get through here. And you see what happens? You make mistakes. I did that on purpose just to show you guys, right? Yeah, right. Much better. Hydrochloric. So when you hear hydro, that means you've only got a monatomic ion. Okay? Hydrochloric. It's not related to chloric acid. Okay, chloric acid means you got those big oxygens bouncing around. Okay? So I just wanted to point that out to you. Now we got 5 minutes left, so we can go just a little bit further here. We're just about finished up everything in the chapter. I tell you what, there is something here. I taught it in my lecture, my Tuesday lecture, and it's such a small, it's at the very back here actually. It's on organic compounds, and to me it's totally worthless because it just gives you one type of organic compound. It gives you other chemistry books would give you alkanes, alkynes, aldehydes, ketones, esters, ethers, to give you a reduction. And this just gives you one thing with the... Read it over if you'd like on page 72. I am not going to test you on it. It takes up about a half a page. No, about third of a page. Okay, so don't worry about that. I'll tell my class and the other time not to worry about it either. All right, now, this side of the eraser works much better. Oh, and it's a beautiful day. Beautiful, beautiful day. Even if we have to sit and listen to chemistry for an hour, right? This won't get you down. All right, now I want you guys to get to work on all this stuff. And I got about 2 minutes left here, so I'll talk extra fast and just to confuse everybody even more. But let's do this. Let's do a compound here with... let's do aluminum and yes, I know that. Okay. I just said it's Friday. That gives me a pass. Okay, let's do this. Aluminum, 3 pluses, the gentleman yelled out in class. That's okay. And we got, want to take a guess at what we call that second guy there? Dihydrogen phosphite. You would have been funny that went to my call. Thank you. Friday. Okay, 2 minutes left. Okay, here we go. How many aluminum to how many dihydrogen phosphites? 1 to 3, correct. All right, so let's put the formula up here. we'll put an Al, and then we'll leave H2PO3. Now it's going to be one aluminum, so that doesn't take a subscript, right? Right? Of course, right. All right, now how do we indicate that there's going to be 3 of these dihydrogen? Uh-oh. That's what you were laughing at, wasn't it, Mr. Nike there? He's laughing, big smile. This is what it can be like, really. I'll distract them, then I'll sneak out. Okay, regaining my dignity. All right, now, how do we indicate that there's 3 of those dihydrogen phosphates? Sir, Mr. Nike, how do we do it? Oh, never mind. Boy, listen to him go. Yeah. All right. The thing is, when we have this, like we need 3 of these guys, how do we indicate it? Well, we could do something like that, but that's not done here on planet Earth. Okay? Maybe in a galaxy far, far away. Okay? We keep the thing compact, but what we do is we put a parentheses with a 3 on it. That means everything inside the parentheses is multiplied by 3. Whoo, yourself. All right, guys, have a good weekend. Okay. Drive safely. Tell your friends about this place. Why do they do this?
Sorry, Mr. Mundell.
Yeah.
I just wanted to ask about the Alex. Is the whole thing due to one time? Or is it like...
It's all due in November. It's supposed to be December. Does anybody see the pen through there? I can't believe this. Somebody... I can't find the stupid pen so I can turn this program on.
Is it?
No. It's just a stylus that goes with this. I didn't even realize that there was a holder there for it. But thank you for finding it. Okay.
You're welcome.